Nature. Peaceful. Serene. Quiet. Actually, not so much. Nature is noisy. It turns out we humans aren't the only animals with a lot to say. But what are they saying? For years, scientists have been learning new languages, trying to make sense of the racket. Until now, it's been all transmission, no reception. But today, new technologies are helping zoologists become better listeners and better translators. And what they're hearing just might surprise you. Animals talk. They may not talk in languages we humans understand, but they're definitely talking. It's not so different for us. Human language may be the most complex of all species. But we have the same basic reasons for communicating. To form and maintain bonds. To express fear and other emotions. Keeping us safe. And to communicate needs. Humans are quick learners, but we're not so good at understanding what other species are saying. Without words to decode, scientists have to rely on the physical analysis of the vocalizations produced. Then pair them with observed behavior. Luckily, all sound works in the same way, as vibrations traveling through the air as sound waves. The pitch of a sound is measured as frequency. That's the number of sound waves produced in a given time. The shorter the wavelength, the higher the frequency, the higher pitched the sound. Slower waves give a lower, bassier sound. The loudness of a sound is determined by the size of the vibration, known as its amplitude. The taller the sound wave, the louder the sound. Analysis of vocalizations in this way has revealed animals use subtle differences in frequency and amplitude to convey different meanings. This is especially true in the most social mammals. From years of watching nature shows, we've all heard the famous trumpet of the African elephant. But there's a whole lot more in the elephant repertoire. These large mammals have remarkably complex social lives, covering close family bonds to broad clan interactions. Because they need to communicate a variety of messages, elephants need a flexible and expressive language. This is where frequency and amplitude come in. This low rumble, with constant changes in frequency and decreasing amplitude, is a greeting to friends and relatives, an established welcome to strengthen bonds. Even slower rumbles are used to transmit travel plans to the herd. And it's not just the adults who vocalize. Calves also rumble when they want to feed, but to an elephant, it's a very different sound, with sharp peaks punctuating the waveform of the rumble. And if the calf doesn't get what it wants, it cranks up the volume. These sharp spikes, loud and high-pitched, are hard for its mother to ignore. While these calls are shared quietly within the group, others are designed to be heard by elephants outside the herd. This loud, high-pitched blast that gently tails off is the call females use to attract passing males when they're ready to mate. And this high, shrill trumpet is used to drive off a threat. But even with this wide range of vocalizations, it turns out an elephant's most amazing vocal trick is one we can't even hear. These large herbivores need to eat a lot. To avoid overgrazing, they have to roam areas as large as 150 square miles, often splitting into smaller groups. But spreading out like this can put members of the herd at risk. Younger animals can get separated and fall victim to starvation, dehydration, or predators. It also makes it harder for adults to locate a mate. Yet elephants always seem to know what the others are up to. So how do elephants communicate over such vast distances? The answer came from an unlikely source. Marine zoologist Katie Payne had spent 15 years studying the songs of humpback whales. But in 1984, a visit to an elephant house sparked her interest. It wasn't what she heard. It was more what she felt.
But I happened to notice that every now and then I was feeling a throbbing in the air, kind of a pulsation in my ears. It occurred to me that this might be sound below the frequencies that I as a human being could hear, and eventually that it might be made by the elephants, and they might be communicating with each other in ways folks didn't know about.
The frequency of sound waves per second is measured in hertz. But we can only hear frequencies between about 20 to 20,000 hertz. Payne knew from her years of research that whales produce sounds in frequencies below human hearing. But could it be that elephants were doing something similar? She recorded an apparently silent elephant, then sped the recording up by a factor of 10. The evidence was clear. The silent elephant was anything but. It had just been communicating at a frequency below what humans can hear. These calls are known as infrasonic and can be as low as a single hertz. What makes them impossible for us to hear is exactly what makes them ideal for long-distance communication, especially at night. During the day, hot air rises and lifts sounds with it. So daytime noises quickly fade into the atmosphere. But at night, when the air cools, sound waves aren't disturbed, so they travel much further. These bassy nighttime rumbles allow elephants to make their trunk calls over distances of up to 6 miles, helping them keep in touch and find each other across vast territories. Scientists are beginning to realize there's a whole lot more going on beyond the reaches of human hearing than we could have ever thought. And now they're starting to explore whether other animals are communicating at an infrasonic level. Like elephants, giraffes wander the African plains in loosely structured herds. But unlike elephants, they don't appear to be the most chatty of animals. When they do make a sound, it's always for the same very specific reason. To signal danger. Despite being the tallest mammals on the planet, giraffes aren't immune to attack. Lions, leopards, and even hyenas can take them down. So they need an early warning system. If a member of the herd spots trouble, it sounds the alarm. A fast, loud coughing or hissing. It's short range, but it lets the others know to run. Giraffes produce these snorts using their nostrils, not their vocal cords. Yet they still have a larynx or voice box. Zoologist Anton Beotik has spent the past 6 years trying to prove that giraffes do actually use their vocal cords all the time. But, just like the elephant's infrasonic rumbling, humans can't hear them.
Like elephants, giraffes come together to socialize, and it might be that giraffes are also producing these very low frequencies for their vocal communication system.
It's a good theory. But Anton's problem has been gathering hard evidence. Tracking and recording wild giraffes is risky. Rough terrain and nocturnal predators are dangerous for a lone researcher. So Anton set up shop at Berlin's Tierpark to record captive giraffes. His state-of-the-art recording equipment scans well below the 20 hertz of human hearing. And when it detects a sound, it automatically records it. After months of fieldwork, Anton had a lot of sound, but nothing he was looking for.
If you're working, for example, in a zoo, the recorder would capture all kind of different background noises from cars, trains, and so on. So this is actually quite challenging.
Determined to prove his theory, Anton tried another approach, radically changing his study timetable to after dark. The African plains are at their most dangerous at night. It's when the most deadly predators hunt. lying down to sleep would leave them highly vulnerable to attack, so giraffes sleep standing up, often power napping for as little as 5 minutes at a time. Even in the safe environment of a zoo, they snooze for fewer than 30 minutes a night. So Anton's next step was to find out if this was when giraffes engage in any form of communication. Learning the languages of animals is challenging enough on land. But it's even harder underwater. It's noisy down here. Constant breaking waves, rising bubbles, fish chomping on hard coral, and the clicking of shrimp. Very noisy. The problem is that it's hard for scientists to pick out individual sounds from the general din, let alone find out what the noises might mean. But advances in technology are making that world more accessible. High-tech recorders and software that isolate particular sounds are now revealing the languages of marine creatures. Among the first to employ these new technologies was marine biologist Dr. Steve Simpson of the University of Exeter. Today, he's brought his team to dive off the Dorset coast in the English Channel.
And you can see there the peak, about 266 hertz.
For almost 2 decades, Simpson has been working to prove not only that fish talk, but they've got a surprising amount to say.
We realised that fish produce sound to communicate for lots of reasons. They defend territories, they attract their mates. We've seen lots of patterns. And one really good example is that every morning, all of these fish that have been hiding in the reef during the night emerge and start vocalising as a way of defending their territory.
So, just like birds, many fish sing first thing in the morning. The result is an incredible dawn chorus. The strange grunts, popping, croaking and creaking calls sound less like melodious birdsong than the voices of alien creatures. But they get the intended point across. This is my turf. One of the most territorial reef dwellers, and consequently the most vocal, is the domino damselfish of the Indo-Pacific Ocean. The male spends much of his time cultivating a small garden of green algae. Turns out the ladies love a fish with a green thumb. If they like what they see, they'll lay their eggs on his garden so he can fertilize them. Unfortunately, his handiwork doesn't just attract females. Other males regularly try to steal his prime spot. It's a lot easier than growing your own garden. So, just like many territorial birds above water, he loudly pronounces his ownership by puffing himself up and shouting loudly. He's hoping the other males will decide he's too big and buff to take on. Elephants vocalize to stay in touch with their extended family. Fish do it to warn off interlopers. And many animals use sound for both. Like the red howler monkey. These primates live in close-knit clans of a dozen or so, with a couple of adult males, several females, and their young. The average human male might brush his teeth or make coffee first thing in the morning. Not so red howler monkeys. They prefer to start their day with a nice round of bellowing. An enlarged hyoid bone, a cup-shaped bone in their throat, resonates, acting like a built-in amplifier. The result is the loudest call of any land animal. The aptly named howlers can belt out calls at a volume of 140 decibels. Louder than the noise of a military jet taking off. Even elephants only manage 112 decibels. Howler monkeys use pure amplitude, more energy in the sound, to project their calls over long distances. They might not have the bass, but they can really crank up the volume. Their booming call can be heard at least 3 miles away. As with the damselfish, it's the howler's way of letting others know that this neck of the woods is spoken for. The howler is a master of broadcasting its presence loudly and widely. Its distant relative in Africa has a far more varied vocabulary, using different calls for different threats. Something our own ancestors might have done in the earliest stages of developing spoken language. Vervet monkeys live in large troops of 50 or so individuals. Although there's some safety in numbers, they can never drop their guard. In Africa, danger comes from all sides. Large eagles can easily pluck a vervet from the treetops. So the monkeys must keep a close eye on the sky. If a member of the troop spots a bird of prey, it sounds the alarm, specific to that predator. A low-pitched grunt. The entire troop instantly knows to abandon the canopy and dash for dense cover on the ground. But what if the danger isn't from the sky? There's a call for that, too. A very different one. This chuttering means, quick, get off the ground. The snake alert sends the troop climbing to safety. So this call means danger, get down from the trees. This one means danger, climb up. But what if you're dealing with a predator that can get you on the ground or in the trees? then of course you need the leopard alarm call. The whole troop instantly dashes for the thinnest branches, which they know can't support the leopard's weight. Getting these signals straight can be a matter of life and death for a vervet. While a variety of calls with complex meanings is something you might expect in primates, Steve Simpson and his students have found that some fish have a surprisingly large vocabulary too. Working on tropical reefs in French Polynesia, the team focused on one species, clownfish. These tiny, colorful fish would be highly vulnerable to predators if it weren't for the fact they live in sea anemones. Anemones are covered in stinging tentacles that they use to catch their food. Clownfish are the only creatures to have evolved an immunity to anemone toxin. Other sea creatures understandably prefer to avoid it. A large anemone can support a colony of half a dozen fish of different ages. At any given time, there's only one dominant female. All the other fish are smaller males. PhD student Isla Keisha Davidson wanted to know if a threatened clownfish broadcasts an alarm to the rest of its community. So she simulated a predatory attack.
So this is the predator model that I was using. It would be attached to some strings so that I could control it a bit like a puppet. And I would swim along the surface with the predator model down at ground level, and he would swim along towards the anemone. And you could see the fish would start paying attention, and they do, they make these little chirpy noises.
To test whether the vocalizations really were an alarm call, she played them back to a different colony. Most of the clownfish reacted to the recorded alarm, then retreated to the safety of their anemone. Only one fish stood its ground, the dominant female, the largest member of the colony.
The clownfish female, she was very defensive and very protective. She knew there were predators around, and she actually came to display to me and tell me to leave her family alone, which I thought was quite brave for a fish that's this big.
Every member of the clownfish colony broadcasts sounds, but they might do more than just announce territory or sound the alarm. They might talk their way out of conflict. The bigger-bodied female makes the deepest sound. The smaller the male, the higher pitched its sound. Isla believes the sounds might help keep the peace. The higher pitch calls of the smaller fish tell the female that they are no threat to her throne. There's no need for her to show them any aggression. Vocal communication in fish is a new science. But already we've discovered they each have their own calls to defend their space, attract mates, send alarm signals, and even maintain social status. Who knows what else they might be saying? It's hard for humans to study individual sounds when they're lost in a sea of noise. But for some animals, picking out a single voice can be the difference between life and death. On the South African coast, female southern or Cape fur seals give birth once a year at the start of summer. This tiny pup is well formed for a mammal its age, with open eyes and working senses. But he can't swim yet and has no blubber to keep him warm in cold seas. So for his first few days, mother and pup are inseparable. With so many seals in one colony, it's easy to get lost. It's vital for mother and pup to recognize each other's voices so they can find each other in the huge, noisy crowd. Which is why each seal has its own unique voice. It only takes a few hours for Mom to learn her pup's calls. For him, it takes a bit longer. Each seal's call can be broken down into key parts that they can all recognize. And he needs to learn to distinguish each of them. There's the frequency, the distinct pitch of the call, and the amplitude, its maximum volume. There are variations in both throughout the call. The combinations of these variables creates a unique code, like a fingerprint. And it had better work, because after a few days, hunger drives the mother to leave her pup and go fishing. It's a dangerous time. Breeding season is still in full swing. Rampaging bulls compete for available mates. To protect her baby from being crushed, the mother leaves him in a sheltered creche or nursery, hoping he'll stay put while she's away. But the pup may not have gotten the memo. After a few hours, he wanders out of the creche in search of his mother. Within minutes, he's lost. Frightened by the sounds of the noisy bulls, he heads away from the colony. Seals are clumsy on land. One false move and he'll be swept away by the surf. Half of all seal pups perish before their first birthday. Predation, drowning, trampling, or the biggest threat, starvation. Finally, his mother returns to the colony, only to find her babies missing. She calls and listens for replies. Mothers and pups use amplitude modulation, AM, the peaks in volume for long-distance recognition. So that's what she does first. Like AM radio, the sheer energy of the sound waves pushes the signal further. The more power behind the sound, the longer it carries. As she gets closer, she listens for the second cue. The frequency modulation, the number of fluctuations that change the pitch of the calls. Like the changing frequency of sound waves that broadcast FM radio, it's not so good over long distance, but it's a cleaner sound with more detail. At close range, she can hear the tiny variations in pitch. Used together, the two traces are unique. Unfortunately, she's not hearing the telltale sound. But then, the pup recognizes a distant voice. He bleats back. Barking back and forth, they listen for each other's unique calls. Bingo! Recognition of an individual through unique vocalizations is common in the natural world. But the more complex an animal's society, the more nuanced its communication system has to be. Of all the large predators on the African plains, the most successful hunter isn't the lion or the cheetah. It's the African hunting dog. Seven out of every 10 wild dog hunts are successful. And it all comes down to effective pack communication. Hunting dogs have a cooperative and highly structured society. The pack forms strong bonds by eating, playing, and sleeping together. African wild dogs have at least a dozen distinct calls, many reinforcing an individual's dominance or subservience in the hierarchy. But these packs also have a surprisingly democratic side. They work together, not only to hunt and maintain their group structure, but also to make group decisions. When the pack is considering its next move, for example, whether to search for a new resting place, look for a watering hole, or go out hunting, its members vote on it by sneezing. Sneeze votes depend to some extent on status. A single sneeze carries more weight from a dominant animal, who only needs 3 other voters to back them for their suggestion to be implemented. But this is a democracy, and with enough votes, other pack members can override their leader's decision. It typically takes 10 voters to get a lower-ranking animal's plan adopted. Enough sneezes, and the decision is made. This time, it's a hunt. Hunting dogs are well-known, well-studied predators. But the sneezes were a surprising revelation for researchers. Even well-known animals can still surprise us with their use of language. The voice of one of Africa's most recognizable animals, the giraffe, remains elusive. At Berlin Tierpark, zoologist Anton Beotik is analyzing the data he recorded overnight. In 2015, after 3 years of listening in, his hard work finally paid off when he recorded evidence of completely new giraffe vocalizations.
When I opened the file and took a deeper look into the recordings, I was just almost like shocked.
There on the recording was a sound no one had heard before.
The humming sounds almost like a whale song, just much deeper.
Anton's theory was correct. Like elephants, giraffes do vocalize at night. But he got one thing wrong. Unexpectedly, although the sounds are deep, they're around 45 to 90 hertz. So, unlike elephant calls, giraffe calls are not infrasonic. They're actually within the range of human hearing. We just didn't hear them because we were never around at night when they vocalized. But burning questions remain. Why do giraffes hum at night? And what do these sounds mean? Anton can only offer an educated guess.
The most likable reason they make use of humming is to keep in touch with group members when vision is limited and they cannot see each other.
Giraffes have excellent vision during the day. However, their night vision is poor, so humming might help them stay in contact with one another while they wander through the bush.
For years, next to nothing was known about the giraffe's vocal communication system. So I'm quite happy to give the giraffes a voice, so to speak.
The discovery of humming has renewed scientific interest in studying what was considered a familiar animal. And it's a very good time for them to be brought into the spotlight. Giraffes are facing extinction. They're slaughtered for meat and trophies and are losing habitat because of human encroachment. Giraffe numbers have declined by 40% in just 30 years. Fewer than 100,000 remain in the wild across the entire African continent. Building a full picture of their ecology, how they relate to each other, how they use their environment, and how much space they need is vital to protecting them. Discovering how they communicate fills in another piece of the puzzle. Animals, everything from seals and clownfish to monkeys, have taken millions of years to adapt their communication to their environment. But over the course of just a century, humans have radically changed these environments. Today, industry and transportation fill the airways and oceans with sound. This noise pollution threatens to drown out natural sound. And it's increasingly difficult for animals to hear each other above the din. Marine animals live in places where visibility is low. They can't rely on vision to find each other, navigate, or find food. Many depend on sound instead, and that makes them especially sensitive to sound pollution. All over the world, fish populations are in decline. Overfishing, pollution, and climate change are to blame. So too is sound. Understanding fish communication is vital to preventing further decline. In addition to their work in the tropics, Steve and his team of students study fish around the UK.
So one of the classic North Atlantic fish, cod, in different parts of its species range, we know that they sound very different. And so that's got us thinking about whether fish actually have accents, local dialects, where these sounds are specific to particular populations.
Just a few years ago, nobody knew fish could speak at all. Now we know cod have regional variations. In effect, different dialects. With this discovery, Steve's poised to see how cod cope with climate change.
As climate is warming, we're seeing populations moving. We know that cod populations are moving further north towards the North Pole. And that's bringing different groups of cod together, perhaps for the first time. If they can't speak the same language, they can't interbreed.
People consume 500,000 tons of Atlantic cod every year. So declining fish stocks could greatly impact human economies and food resources. Cod also play a vital role in the ocean food chain, feeding on smaller animals and becoming prey for larger ones. So shifts in their populations impact whole marine communities. Now Steve's pioneering research might offer ways to combat fish decline.
I've been working on the Great Barrier Reef for about the last 15 years, taking recordings in lots of the same locations year after year. And over the last 5 years, there have been 2 cyclones and 2 years of bleaching, which has meant the reef has gone quiet.
When water is too warm, corals expel the algae living in their tissues, causing them to turn completely white. It's known as bleaching. It may not kill the corals, but it greatly reduces their productivity. Fish often abandon these struggling reefs. But Steve's underwater recordings may help to bring them back.
By using our historic recordings, we've found that fish are still attracted by these sounds. If we build an artificial reef, we can call the fish into those reefs. But if we use recordings from today's conditions, the fish are no longer interested in it. So that really begs the question, can we use historic recordings to call the fish back in and help to restock reefs in the future?
Science is just beginning to unravel the mysteries of animal communication. After years of research, we're discovering that animals have a lot to say and have more sophisticated communication than we ever imagined. Decoding and harnessing that knowledge may help us restore wildlife populations and keep the world a noisy place for generations of animals to come.